All right, so I'm just recapping from the middle of your notes here. It says each week you have 2 Google Meets for math class. I wish you had 5, but that's a story for another day. Fill in the table below, given that weeks is X and the number of math Google Meets is Y. So let's say we had 0 weeks of school. That would be a dream situation for some of you, I bet. That would mean you don't have any Google Meets. That just makes sense, right? And this is when we know this is a proportional relationship. I put down 0, 0. So therefore, we have a proportional relationship. If I have 1 week, there's going to be 2 Google Meets. If I have 2 weeks, there's 4. And this is probably not exactly translating to real world because you're going to have weeks like, the week for Thanksgiving where you only have 2 meets. But just go with me on it. Let's assume that it does always work this way. So when you get over here, if you just have plain old x, to get from x to y, you have to multiply x by 2. So another way of saying y is just to say, 2x. 2x and y are the same thing. And so since 2x and y are the same thing, segue, pick an equation that can be used to summarize how many meets there are per week. So if we look at this, slide 10, which is the next slide, I'm going to worry about that in a second, but we just said that y, the number of Google Meets, is equal to the number of weeks times 2. So it would be this one right here. The other ones are all tempting, like especially this one right here. I've seen a lot of students pick this. And that's an ordered pair in this situation, but it's not an equation that describes the relationship. On screen 10 right here, I think they were asking us right here to type that equation into the tab. So y equals 2x. If I type that in, you see how it goes through the origin. You also see this point right here, which, there it is, 1, 2. And that, I think, appears in our table. And so it should make sense that the graph and the table are coordinated together, right? They're trying to describe the same situation. If I look at y, it's increasing by 2 each time here. And you look at x, it's increasing by 1. If you look at that graph again, when I go up 2, which is like going up 2 on y, I go up 1 on x, which is going to the right. If I go up 2 on y, I go up 1 on x. And that's the situation throughout here. Now, this part at the lower end probably doesn't make sense in real-world context. If I have negative Google Meets or negative weeks, I don't think such a thing exists. So I would probably have to change this graph up so it just shows the origin and on. And this is called quadrant 1 up here. But you get the general idea. On 11 here, is that an example of a proportion? Yes, of course. The graph goes through the origin. The other thing that you could say is that each time you're multiplying by the same value, and you don't have to add anything or subtract anything, right? Going back to that equation, just said 2 times x. If the rule was y equals 2 times x plus 5 or something like that, it would mean it's not a proportional relationship. But just for your simplicity, the graph, I skipped the word goes. I can't type. The graph through the origin. The graph goes through the origin. And we'll hit submit there. I'm not going to do that, but you will. Here's another equation, y equals x over 4. You can plug in any value for x because there are infinite solutions to this equation. Anything will work for x, literally. This isn't even like the last one where you can have negatives here because we don't know what it's about. It's a mathematical problem, so we got to assume there's negatives. What values of x do you think will be easiest to calculate in your head as you fill out the table? I would pick any number that is divisible by 4. Because if you pick a number like 3 or 7, it gets kind of messy. You have these fractions and improper fractions. So what I'm going to do is I'm going to pick 0 because, hey, 0 divided by 4 is 0. Oh, proportional relationship. What do you know? If x is 4, 4 divided by 4 is 1. And this is pretty, isn't it? Nice, clean, whole numbers. Snuggly, wuggly, queen numbers. We call these integers, right? So you can see I've got different values for x. I mean, if I wanted to, it wouldn't be wrong right here to type 20 as long as I type 20 divided by 4, which is 5. I'm just going to leave it as 12 because I think that's the simplest way to explain this. On the next screen, pick any 2 points from your table and put them on the graph. Let's go with 0, 0, and 4, 1. Let's do that. So we've got, are they going to let me do that? Come on. Well, they're not letting me do that, so let's do this. Let's beat them at their own game. We go to Desmos.com, and I hit graphing calculator. Again, I'm going to put the point 0, 0, and we got to use parentheses when we do that. 0, 0, just to show you 4, 1. If I didn't use parentheses, it comes up right there, and they say, hey, you, parentheses. So I put the parentheses there, and then the other thing that they asked me for, if I just go back to slide 12 here, it said, then put in the equation y equals x over 4. And to do that, what I would have to do, there's y equals, you need the slash button, and it defaults right to a fraction, and there you see it. You can see that the green line goes through those 2 points. So I'm going back here. I'm going to skip slide 13. I just did that on the other slide. Is this proportional? Yes. The line goes through the origin, right? The ordered pair 0, 0 is in the table. You could also say that. Slide 15 right here, it says which of these is a proportional relationship between x and y. X is 0, y is 2. That's not proportional. X is 0, y is 0. That is. So I would just say the one on the right. The ordered pair 0, 0 is there. All right, and then the last thing we're going to do is slide 16 right here. Fill in the table based on the equation above. I'm just going to put in 1 point. Let me do this. I'll put in 1 point. Negative 2 times 0 is 0, plus 3 is 3. So there's the equation y equals negative 2x plus 3. I'm going to plug in 1 for x, negative 2 times 1. So negative 2 times 1 is negative 2. And then if I add 3 to that, it's going to equal 1. So I could say x is 1, and then y is 1. Let's try one more. If I got y equals negative 2x plus 3, I could plug in 2 for x this time. Negative 2 times 2 plus 3. So negative 2 times 2 is negative 4. Negative times a positive is a negative. And then if we're adding these, I have more negatives than positives. So it's going to equal a negative, and there's one more negative than there is positive. So I'd put y as negative 1. So when x was 2, y was negative 1. And you catch on with a little pattern here. You notice how x is increasing by 1 and y is decreasing by 2. If I wanted to keep going, I could keep increasing x by 1 and y by 2 would then decrease by 2.